In this chapter, and the videos for this chapter, we will be discussing how to do detailed design using communication diagrams and sequence diagrams. In this video, we will discuss what is meant by use case realization. Then we will discuss the information contained in a communication diagram. Use case realization is that process which elaborates the detailed design of a use case using interaction diagrams. The objective of this detailed design is to identify all of the objects, or the object classes, and the interactions, or the messages, that are required to execute a use case. Remember from the last chapter you learned that the output of the detailed design is a set of design classes, as shown in the design class diagram, which have method signatures defined. The messages identified during the realization of a use case provide the information to identify and define those methods. In earlier videos, you also learned about software layers, namely a view layer or user interface layer, a domain logic layer, and a data access layer. This is called three-layer design. Developers utilize three-layer design to implement the principles of good design that you learned about in the previous chapter. Three-layer design is a direct result of utilizing the principles of separation of responsibilities, object responsibilities, high cohesion, and low coupling, as well as protection from variations. Each layer has a specific purpose. Most of our design effort will be spent elaborating the design of the domain layer. Once we have the detailed design for the domain layer, which are the entity classes, then we add the view layer and the data access layer. There are two types of interaction diagrams that are used for use case realization: communication diagrams and sequence diagrams. Both types of diagrams contain basically the same information. The layout and syntax of each is slightly different. Because the layout is different, the focus of the diagram is also slightly different. A communication diagram is more of an overview of the use case. Its emphasis is on the entire set of objects involved in the use case, with less emphasis on the messages themselves. A sequence diagram, on the other hand, tends to be more focused on the details of the messages, with much more emphasis on the flow of the message sequence. This class diagram describes the structure of these diagrams, of these two interaction diagrams. This will be a good review for the usefulness of a class diagram. Since interaction diagrams are things, we can develop a class diagram. Notice that the interaction diagram class has both a message class and an object class as composite classes. The message class is considered a composition since the messages themselves don't really exist other than as part of the interaction diagram. The object class is considered an aggregation because we do often draw objects on other places besides an interaction diagram. Both a communication diagram and a sequence diagram are subclasses of interaction diagram class. Hence, they both contain messages and objects because they inherit them from the interaction diagram class. A communication diagram has links, which are represented by lines. A sequence diagram has timelines, which are represented as dashed lines, which we will learn later on. You were introduced to the concept of a use case controller in a previous video. We will explain a little more about its use. First, note that it is a completely artificial class. It does not come from the problem domain classes nor the view layer classes. It is something we create as part of the design process. A use case controller acts as the switchboard between the user interface classes and the domain layer classes. Why do we add it? Well, we do because it reduces coupling between the view layer and the domain layer. For example, let's envision a use case that had 5 input screens. This system also needs to be desktop and mobile device compatible. So we have 5 screens for the desktop system and maybe 5 or more different input forms for the small screens on the mobile devices. Without the use case controller, each of these forms would have coupling directly into the various problem domain classes. If we changed any problem domain classes, we very possibly would have to redo many view layer classes. However, if all the view layer classes always sent their messages to the use case controller, changing the problem domain would have little or no impact on the view layer. During design, we usually identify a use case controller for each use case. In reality, however, we often combine similar use cases together and let a single controller handle all of them. This figure illustrates the elements on a communication diagram. The stick figure is called an actor and represents the external role of the person or thing that initiates the use case by sending in messages. The rectangles represent the instantiated objects that perform the actions to carry out the use case. These objects receive messages and send other messages. The notation that we use for an object is a colon and the class name, all of which are underlined. If there is a need to specifically identify the particular instance of an object, an identifier for that object is placed before the colon. This is called a named object. In this diagram, we have named both objects as O1 and O2. An identifier or name might be required as a reference in a message parameter or as a returned value. The lines between the objects and to the actor are simply connectors. They are called links. You can think of them simply as conduits to carry the messages. They have no other meaning. Finally, the messages themselves. Each message has an origin, either a class or an actor, and a destination, as indicated by the arrow. The numbers on the messages help to identify the sequence of the messages. Here's the syntax for a message on a communication diagram. In the brackets is a true-false condition. This is a guard to test if the message can be sent or not. If the guard is false, the message is not sent. A sequence number, because messages on a communication diagram are not displayed in any particular location or arrangement, this is the only way to indicate the sequence of the messages. Sometimes dot notation is used, such as 1.1 or 1.2 to indicate the sequence of related messages. A return value is placed on the left of the colon equals operator sign. This is the value that is returned from the message destination object. Often it is a reference to a named object. The message name followed by the parameter list in parentheses. Message names are usually in camel case notation. The name of the message also should reflect the requested service from the destination object. Finally, any of these constructs are optional and may be omitted. Only those elements that have data or meaning need to be included in the message syntax. This sample communication diagram illustrates how a communication diagram documents a use case realization. In the Create Customer Account use case, there are 3 input messages defined. The first input message, named Create New Customer, creates a new customer object. The second input message adds address information, and the third input message adds credit card information. Previous to this step, a first cut design class diagram was created with 4 classes: the customer handler class, the customer class, the address class, and the account class. In interaction diagrams, we use object notation with stereotype notation as necessary, and object names and object identifiers. Attribute information is not included, neither are relationships. The first input message is numbered 1:. It is located between the actor and the customer handler object, such that the actor is the source and the customer handler is the destination. 4 parameters are included and passed with the message. The customer handler object receives this message and sends a related message to the customer object. We can tell it is an extension of the original message because it is numbered 1.1:. It also has the same name and the same parameter list. The destination for message 1.1 is the customer object. We assume the customer object processes the message with an appropriate method, and then it returns back a reference to itself. In message 1.1, we see the return value of C being returned to the customer handler object. We note that the return value is the same as the object identifier for the customer object, namely AC. There are no other related messages for this initial message. Note that the customer handler now has visibility to the newly created customer object. This should also be indicated on the design class diagram if it's not already there. Next, observe message number 2. It is similar, except that the message name also includes an asterisk. The asterisk indicates that this message is a repeating message. In other words, it may be sent multiple times by the actor. We assume that a customer is allowed to have multiple addresses in the system. The parameter in message number 2 is simply address information. Obviously, this is some sort of generic reference to detail parameters. It's kind of a shorthand notation for the details that are not shown. Message number 2 is forwarded by the customer handler to the customer via message number 2.2. The customer object then forwards a related message, number 2.3, to the address object. The customer object sent a message with a slightly different name, create address. In message 2.3, the figure also elaborates on the detail parameters. The parameter details are account number. We assume it's a customer number and came from the class diagram. A type code, and then detail address fields. In message 2.3, a reference to the newly created address object, namely add, is returned to the customer object. The customer object now has visibility to this address object. Message number 3 is similar to message number 2. It is sent to customer handler, which sends message 3.1 to the customer object, which sends message 3.2 to the account object. In message 3.2, the parameters are also elaborated in more detail. A reference to the account object is returned to the customer object. Note that the returned values for address and account are returned to the customer but not to the customer handler. Customer handler does not need nor have visibility to those two objects. This diagram only shows the problem domain classes and the controller class. In other words, this is only the design of the domain layer. In later videos, we will demonstrate the view layer and the data access layer for use case realization. This explanation should help you not only to understand how to read and understand a communication diagram, but it should also have given you a better understanding of what is meant by use case realization.